I'm not going to be able to bring it home. I'm leaving my backpack to do that.
Can you put them in your backpack?
I know, because I'm taking some stuff in my backpack, but not everything.
Okay. On with our geometrical hoops. What we're going to have to figure out, this is the challenge. You have a robot at point Q. You want it to get to point P, but you're only allowed to travel in the direction of A and B. How do we do that? Okay. So what do we have? What do we have right now? We have a parallelogram, and we know that OB is a vector B, OA is a vector A. We know that C to Q, the ratio of C to Q and Q to B is 1 to 3. So that means this length could be a ratio of 1 and a ratio of 3. Does it make sense then that CQ is 1/4 of CP? If you have that ratio of C to Q and Q to B being 1 to 3, then you know that C to Q is 1/4 of the way from C to B. And then we have another ratio where this length to this length is 2 to 1. Now we can't really write the numbers, like I wrote 1 and 3 and 2 and 1 there, but those aren't actually lengths. They're just for me to think about ratios. Because I hope you can see that my number 2 looks like it's a heck of a lot bigger than my number 3. But they're ratios. So that means that B to P is 1/3 of A to P. So we're going to have to use those ratios in this question. So first of all, if you wanted to just go from A to B, all right? If I wanted to go from A and go to B and I was only allowed to travel along the paths of A and B, I think I would go back along this way and then along that way to go from A to B. So that's just going to be A to O plus O to B. And A to O is negative A, and O to B is B. So I get negative A plus B. Ratio-wise, now I want to go from A to P. Ratio-wise, does it make sense that A to P is 3/2 of A to B? Because if this has a length of 2 and this is a length of 1, this is going to be 1.5 times A to B. Because A to B would be 1 times, and then you add another half, so that would be 1.5 times as well. I find in these questions, sometimes just the mental math of the ratios is sort of what might slow you down, might have you think a little bit. So in that mind, right, or you could think of it this way, instead of having the 3/2, you could say I'm going to go A to B, and then I'm going to go another half of A to B, which makes 3/2 A to B anyways. And A to B I already figured out was negative A plus B. And I can distribute that 3/2 and get negative 3/2 A plus 3/2 B. So now we want to go from Q to P. if I'm going from Q to P using the pathways that I have, I mean, how could I do that? I could go back this way, then down this way, then over this way, then all the way up this way. That would work. So now I just have to figure out what each of those things would be if I was using them. But part 3 and part 4, sorry, I'm skipping ahead. I already was on part B. We'll do it easier. Part 3 says, can you find O to P and O to Q? So first of all, in blue here, we're going to want to find, that's not blue. In blue, we want to find O to P, and in green, we're going to find O to Q. So from O to P, I could do that by going O to A. Show that in blue. I can go O to A, and then I already figured out A to P. Or I could go to O to B to B to P. Either one. I'll erase that because I thought I did this one first. Go O to B, and then B to P. What would that equal? Well, that's vector B. And that one was half of AB, negative A plus B. Again, just simplify from there. And we get 3/2 B minus 1/2 A. If I want to go from O to Q, I can go first from O to C, and then C to Q. And O to C is the same as A to B, because vectors are free. And since it's a parallelogram, opposite sides would be equal. And we already talked about how C to Q was 1/4 of C to B. And again, since it's a parallelogram, C to B is parallel and equal to O to A, so we can replace that with O to A. And A to B was negative A plus B, and the arrowheads. And O to A is A, so simplifying this, we get negative 3/4 A plus B. So now that you've found O to Q and O to P, it would be really easy to get your robot to go from Q to P. Question?
Do we only get one counter vector, like sides of one things at the final answer, or do
No, all the way through.
all the way through?
All the way through.
How do you know that C to Q is 1/4 of C to P?
So when, if we go back to the initial one, with the ratio that they had, C to Q, Q to B is 1/3. So this length would be 1 to this length would be 3. That's what that ratio means. So the whole length is 4.
Okay.
And so that makes C to Q 1/4 of the whole thing. Now we don't know what units that is for something. That's why I changed the color, because it's not actual length of 3. They're just telling you the ratio is that. But if you put the actual numbers in, you could say, oh, if I think of it as a length of 4, and this is a length of 1, then this is 1/4 of the whole thing. So now we can get from Q to P by going from Q back to O, and then going from O to P. And Q back to O is just the negative of of what we had before, so now that's 3/4 A minus B, and O to P was 3/2 B minus 1/2 A, and you could simplify this, and apparently, it's going to be 1/4 of A and 1/2 of B. I'm going to test that out by drawing on top of here. Here's half of B, and to the best of my ability, that looks like 1/4 of A. So if I put this onto Q, that's pretty close. It might have been that my original drawing wasn't to scale, and then that would throw it off. Or maybe I just didn't draw my half of B quite long enough. All right, I want you to try this next one on your own. Draw a picture. There we go. Did you get that O to B was A plus B? And did you get that C to A was negative B plus A, or A minus B? And one of the things that you could do is, when you're finding the length of O to B, you could just say, well, I know this is 8 and I know this is 6, so I can get A squared plus B squared equals C squared, and I get 10. What is the length of OB plus CA? OB plus CA. Okay. And this is where vectors are nice to be free. Because if I have OB like this, and CA, adding it would go like this, can you see that you would have, whoops, I'll do it blank. O to A to there, and then you would have the same length again? So drawing the picture with the vectors, I can tell that this length is going to be 16. Doing the math with the vectors, add a little arrowhead here. A plus B, B minus A, adding them together, you get 2A, and sure enough, that's going to be 8 plus 8, 16. Oh, not all of these little arrowheads, sorry. If you go from O to A to C, if these middle numbers are the same, does it make sense that you started at O and are now at C? And then if you're at C and you go from C to O, uh-oh, you get to, uh-oh, 2 O's, which is just the 0 vector. You're back to where you started from. Uh-oh. I liked it. I thought it was terribly fun. But since nobody's laughing and it's a Friday, oh, now you're laughing at me. As soon as I start to cry.